In the last section, we figured out how to create a new struct and then embed that into an existing one. So we created contact info. We then added a new field name of contact to person, and we said that the contact field would always have a value of contact info. Then when we created a person, we said, okay, here's our contact field, and here's the contact info to use for it. Now, there's still a couple things I want to show you around structs, and the first one is one last little piece of kind of trivia around creating an embedded struct like we just did. So we had said that we had a field name of contact right here, and its type was supposed to be contact info. Now, I want to show you one other way to embed a struct that's just about equivalent, it's just slightly different syntax. So if we want to, we can remove the field name right here. We can remove contact, and we can say simply contact info. Now what this does is it still declares a field name of contact info, and it also says that it's supposed to have a type contact info. So in other words, using just contact info right here is 100% equivalent to saying contact info is the field name and it has a type of contact info. That's a tongue twister, I know. So let's leave it at just contact info and see how we would actually make use of this. So I'm going to leave contact info right here, and then down inside of our creation of Jim, rather than declaring the field name of contact and assigning it contact info, we'll say contact info is supposed to be of type contact info. I know I'm saying that a lot. All right, so let's save this and test it out. So essentially all we have done is renamed that one field so that we don't have to say contact, we're just saving ourselves some keystrokes here. That's all we're really doing. So let's test it out again. And you'll notice, okay, so here's the field name, still contact info, and it has a value of type contact info. All right, now that might seem like a little unimportant piece of trivia, but that's actually going to be kind of important later on, especially when we talk about getting some real code reuse with Go. So I want you to just kind of file this little fact away that we don't actually have to specify the field name here if we don't want to. Okay, so let's continue on. There's one last thing I want to look at somewhat quickly around structs. Inside of our deck application or the cards application, you'll recall that when we created that new type of deck, we then set up some functions that took the deck as a receiver. And the result of that was that we could write code that looked something like, cards.shuffle or what have you. And so we can set up the same type of functions that have receivers with structs as well. So let's create a new function that will take a person like Jim as a receiver, and maybe we'll just print out all the details of that person. So we're going to have to kind of reach into our memory here and remember how we create functions that take a receiver. Underneath our main function, we'll write out func. We'll then write out the receiver. So this will be p person, which means you can call this function that we're about to define on any type or any value of type person. And then inside the body of this function, you can reference that person as the variable p. So we'll give this thing the name, how about just print? Like so. And so we're going to say basically exactly what we were doing right here with the printf statement. So we'll just cut this line, paste it right here, and then of course, rather than attempting to print out Jim, we want to print the person who was fed into this function. So we're going to say printf second argument of p. Okay, so now inside of our main function, we can freely call Jim.print. Specifically because we just set up this function with a person type as the receiver. And Jim is a person. Okay, let's save this and test it out and see how we're doing. So I'll save the file, we'll flip on over, and okay, looks good. Now there's one last thing that I want to do with this struct that's very much like this receiver stuff right here that's going to lead in very nicely to our next topic. Okay, so the next topic we're going to be discussing is going to be a little bit of a doozy, but we're going to put together a little code snippet right now that's going to work a little bit unexpectedly, okay? Or maybe it'll work exactly as you expect. We'll see. Let's write the code out and we'll just see what happens. So I want to create another function called, how about something like update name? All right, I want to write a function called update name that takes a person as a receiver and then updates the first name property on that person. So let's give this a shot. I'm going to say func p person. The function name will be update name. And then maybe we'll receive the new first name. So we'll just call it very explicitly new first name, which should be a string. So we'll say p.firstName equals new first name, like so. Okay, so we just declared this function, update name. It has a receiver of type person, and we are supposed to call it with a new first name. And then when we do, it'll update that person's first name. So let's call this with Jim, and let's just give Jim a new first name and see what happens. So we'll say Jim.update name, and we'll give him a new first name of, how about just Jimmy? Okay, so I want you to sit down for a second, and I want you to look at the code that we just wrote right here. I want you to look at this function, and I want you to kind of form an opinion right now. When we run this code, what do you think exactly is going to happen? Okay, I want you to just kind of think about it for a second. Think about what's going to happen when we run this. I can guarantee you it's going to run. Like, we're not going to get an error, but I just want you to kind of get some idea of what you think should happen. Okay, and then when you've got that idea, we'll flip on over to the terminal and we'll run our program again. So when we run our program, you'll notice that we have a first name here of Jim. Now that might be a little bit interesting to you, because on this line right here, we're saying take Jim, pass him into update name, so Jim is going to be p person right here, and give Jim a brand new first name, like update that first name property. And then immediately after that, we print out Jim again. So it kind of seems to me like when we print Jim out right here, we just updated his name to Jimmy. But clearly, as we just saw when we printed it, it looks like that update did not take effect. It did not take hold at all. So this is an actually very interesting part of Go, and it's going to segue very nicely into our next big topic, which is to talk a little bit about pointers in Go. So let's take a quick break. We're going to come back in the next section, and we're going to jump into this next big topic and talk a lot about pointers and exactly what they are used for in Go. So quick break, and I'll see you in just a minute.